In this question, we're asked to predict whether a reaction occurs between two ionic compounds in aqueous solution. And if one does, we are to write a balanced total and net ionic equation for the reaction. The essence of this question is knowing what compounds are insoluble. Because in order for a net ionic reaction to occur, ions have to be removed from the solution. And in the case of these examples, this would be done by the formation of a precipitate, an insoluble compound. So we have to consider in each case whether or not any combination of the positive and negative ions will be insoluble. In the case of iron 3 chloride, we have Fe3+ and Cl-, and with cesium phosphate we have Cs+ and PO4 3-. Now the question is, would the combination of iron phosphate be insoluble, or would cesium chloride be insoluble? And the answer is that phosphates of metal ions like iron are in fact insoluble. So we would expect there to be a reaction. It would look like this: FeCl3 aqueous plus cesium phosphate would have a formula CS3PO4 aqueous, and the insoluble compound would be FePO4. This would be a solid, iron 3 phosphate, and then cesium chloride would be aqueous. So the net ionic reaction would be Fe3+ aqueous plus PO4 3- aqueous gives FePO4 solid. Now in choice B we have sodium hydroxide, which would be sodium ions and hydroxide ions when it dissolves in aqueous solution, and cadmium nitrate. Cadmium is Cd2+, and nitrate is NO3-. Now all sodium compounds are soluble, and all nitrate compounds are soluble. But cadmium hydroxide, metal hydroxides other than group 1 and the heavy group 2 hydroxides, other metal hydroxides are insoluble. So the reaction would be sodium hydroxide, 2 of them, aqueous, plus cadmium nitrate, CdNO3 taken twice, aqueous, goes to CdOH taken twice, solid, plus 2 sodium nitrate, aqueous. The net ionic equation would be Cd2+ plus 2OH- aqueous gives CdOH taken twice solid. And that would be the net ionic equation. So the sodium ions and the nitrate ions would of course be spectator ions. Number C is magnesium bromide plus potassium acetate. Magnesium bromide is MgBr2 aqueous plus potassium acetate. This is KC2H3O2 aqueous. Now, the solubility rules say that all potassium salts are soluble, and acetate compounds are also soluble, ionic compounds of acetate. So there is no driving force for any reaction here. All that happens in this case is we would just form the ions in solution. Mg aqueous plus 2Br minus aqueous plus K plus aqueous plus acetate C2H3O2 minus aqueous. And there would be no net reaction because there's no solid formation. Finally, number D, we have silver sulfate and barium chloride. Silver sulfate would be AgSO4 aqueous plus barium chloride would be BaCl2 aqueous. So the ions that we have would be silver plus, sulfate 2 minus, barium 2 plus, and chloride ion. Now, the combination of barium and sulfate is insoluble, barium sulfate, and the combination of silver and chloride is insoluble. So this reaction produces two precipitates, and that is silver chloride, and there'll be a 2 in front of this to balance it, 2 silver chloride solid, which is insoluble, and 1 barium sulfate solid. The net ionic equation is 2Ag plus aqueous plus SO4 2 minus aqueous plus Ba2 plus aqueous plus 2Cl minus aqueous goes to 2AgCl solid plus barium sulfate solid. So in this case there are no spectator ions. Everything changes, and the net ionic equation involves all of the ions. They all disappear from solution to form two different precipitates, barium sulfate and silver chloride.